Today we look at the laws of logic. That includes the law of detachment and the law of syllogism. In addition, we look at conjunction, disjunction, and biconditional statements. Here are your essential questions for today. When is a conjunction true? When is a disjunction true? Explain how the law of detachment works and write 3 conditional statements to illustrate how the law of syllogism works. Let's activate the lesson by having you take a peek at all of these conditional statements and reorder them in a way that makes sense. Statement number 1 should be, if the Falcons score, the game is over. Statement 2, if the game is over, Brad will come home. Number 3, if Brad comes home, he will open the cage. Number 4, if the cage is open, the bird will fly out. And finally, the Falcons scored. So in conclusion, we can ultimately say, if the Falcons score, the bird will fly out of its cage. A biconditional statement uses the phrase if and only if, and it can be read from left to right or right to left, but either way it's true. For example, a triangle is right if and only if it has a 90-degree angle. You can read it from left to right this way. If a triangle is right, then it has a 90-degree angle. Or, let's read it from right to left. If a triangle has a 90-degree angle, then it is right. Can we rewrite this sentence as a biconditional statement? Let's see. How could we use if and only if? How about, lines are perpendicular if and only if they intersect to form right angles, specifically 4 right angles. Can we write this one as can we say an angle is obtuse if and only if it measures 150 degrees? No, we can't. Therefore, it's not possible to write this one as a biconditional. In this example, while we can write integers as rational numbers, not every rational number can be written as an integer. So this is also not possible to write as a biconditional. All right, now in a conjunction, it is a compound statement separated with the word and. Both parts of the statement must be true for the conjunction to be true. So here we have 3 conjunctions, and let's see if they're true or false. Statement number 1. Are both parts of the statement true? Yes. Then the conjunction is true. Statement number 2 is false. Can you see why? And statement number 3 is clearly false because neither part is true. How about a disjunction? It uses the word or. And either part may be true, or both parts may be true for the disjunction to be true. So statement number 1, is it true? Yes, it is. Statement number 2 is true because one part of the sentence is true. Statement number 3 is false because neither part is true. All right, I want to look at deductive reasoning now. Simply put, it is the process of drawing conclusions using reasoning from given statements. So we want to try to draw conclusions. First, let's look at the laws of logic. We have the law of detachment. If P, then Q. So it's a simple conditional statement. We find out that P is true, therefore we can conclude that Q is true. In the law of syllogism, we have 2 conditional statements. If P, then Q. If Q, then R. We find out that P is true, therefore we can conclude that R is true. Example. Can we draw a conclusion? If the sum of the measures of 2 angles is 180 degrees, then the angles are supplementary. And then we're given the sum of the measures of angles A and B is 180. Yes, we can make a conclusion that angles A and B are supplementary by the law of detachment. Okay, this is a simple example. If it is raining, then it is cloudy, and yesterday it rained. we can definitely draw a conclusion that yesterday was cloudy. And that's by the law of detachment. Here we're given two conditional statements. If two angles form a linear pair, then the two angles are supplementary. And if two angles are supplementary, the sum of their angles is 180 degrees. Can we draw a conclusion, or can we write a third conditional statement? Yep, the sum of the angles of a linear pair is 180 degrees. We could also have said, if two angles form a linear pair, then the sum of their angles is 180 degrees. That's by the law of syllogism. Okay, interesting example here, and one that catches a lot of students. If Meg wants a good pizza, she goes to Bertucci's. That's the statement that's given, the if-then. But notice Q is given, not P. Meg went to Bertucci's. We cannot draw a conclusion because P was not given as true. Rather, Q was given as true. If a tree falls down on electrical wires, we will lose power. If we lose power, there will be no school. So we can draw a conclusion as follows. If a tree falls down on the electrical wires, then there will be no school. That's the law of syllogism. Remember our essential questions from today. Are you able to comfortably answer them with confidence? When is a conjunction true? A conjunction is separated with what word? And both parts must be true. When is a disjunction true? Well, that's a sentence that's separated with the word or, and either part must be true for the disjunction to be true. Law of detachment. Remember, that's the one where one conditional statement is given. If P, then Q. We find out P is true, so necessarily Q must be true. And the law of syllogism. That's the law that says if you have two conditional statements where the hypothesis of the second statement is really the conclusion of the first, then you can shrink down those two statements to form a third conclusion statement.